episode number 5. Today we're going to play a lot with ejection and with our lifter function within XMD. I'm going to show you how to utilize those and how to use some other commands that are related to this, things that you may have to do in the real world to meet the needs of your design. So the first thing we're going to do is I've decided I want to make my core block a little bit thicker. I want a little more space underneath where my lifter is going to go. I'm going to have a lifter in this area, and so by the time I have the bottom of my lifter, the steel is going to be a little thinner than I'd like, so I want to thicken the block. So very easy to do. If you remember in previous tutorials, we have our block editing tool. So when we go in here, we have all our mold parameters, which handles all our plate sizes for our ejection rails, and it displays what our core and cavity block sizes are. But because I want to change the back of block, and that affects a lot of features as far as mating and length of pins and the location of your pillar supports and things like that, what we do is we go into our parting line lock editor. So I'm going to go in there, and in here we're able to make some changes. So what I want to do is I want to increase the block size to the back of where the back of block is going to be. I'm going to add 2 inches to the back of that. So the first thing I'm going to do is I'm going to unfreeze. These dimensions that you see in green are frozen. So if you don't unfreeze dimensions that are affected by the value you're changing, XMD will come back and say, hey, you've frozen those, you can't make a change. So it's to make sure that you don't make changes that you inadvertently. So what I'm going to do is I'm going to go in here and I'm going to tell it that I want to add 2 inches. So I'm going to add 2 inches to the back of block. So from my Z0 line to the back of block, an additional 2 inches. Okay? So from there, it's increased that in this display here, and it's letting you know that you're going to be just under a 10-inch block thickness. This is perfect. I got 25,000 stock. A little bit of stock will probably be on that block when it comes in from the mill, so that should be good. We're going to utilize as much of our steel as we possibly can. So I'm going to go ahead and accept that, and we can say OK here too, and it's going to redraw all that. So now what it's going to do is it's going to increase our block thickness. It's going to modify the solid for the core block. It's going to shift down the rails and the ejection. It's going to increase the length of our return pins. It's going to adjust our bushings. As you can see, the bushings have a longer pipe spacer there now, things like that. So along with that, it also updates our material list. So you'll see the core block is now 10 inches thick. And like I said, anything else that's increased in length, such as return pins, that's all updated in here automatically. So the one thing that I do see that we still need to do is our screws for those inserts. So it knows to move those screws back, but it didn't really understand, well, where does those threads have to start? So what we're going to do is we're going to modify that. I'm really glad we got to see this, because this is a modify command that you're going to get to see. So what we're going to do is let's just reduce this a little bit just by turning on just my core and inserts, just so I got a little less detail on. And we're going to say show components as well, just so you can see the screws change. So what we're going to do is we're going to use, under our modify command, we're going to use our modify size. You remember in previous tutorials, this modify size can be clicked on any XMD component, and anything that relates to that component that's modifiable will automatically be brought to your attention. So when I say modify size on this screw, these are the options that I have for modifying that screw. So what I want to do is I want to make sure I modify all of type, because I want both those screws to change together. Right? If I say single, only the one will change. So I'm going to say I want to redefine line. And this works exactly like in our previous tutorial, in our last tutorial, where we were showing how to add screws. So where you choose where the head's going to start and where the thread's going to start. This works exactly the same. So you have the choice of doing it in 2D, where you're going to choose lines, or in 3D, where you'll choose faces. In this case, we're going to do it in 3D. So I'm going to just say the screw is going to stay at this face, back of the core block, and our thread is going to be at the beginning of this insert. Okay. Say accept. That's it. Now our screw is fixed. It's increased the length of our screw, and our material list is up to date, and everything all at once. So now I'm really happy with this job. I'm okay with the thickness of the block. I think this is going to work out really good for my lifter. Okay. So that's what we're going to do next. We're going to go ahead and place a lifter. So under our add commands, we have a lifter function. So what this is going to do is this is going to automate putting in the lifter. It's going to block in a basic lifter head for us just to get us kind of started, towards the end of this tutorial, we're going to go ahead and model in the pocket and the lifter itself. And we're going to put in, it's going to put in our lifter rods and our screws to hold down our gib assemblies and everything. I have several ways to indicate what the undercut amount is. One way is to go in here and manually type in my value. Another way, which we made just to make it a little simpler so people don't have to remember numbers, is they can go in there and dimension all their undercuts if they want. And now what we can do is just select that actual dimension by clicking on this icon. I pick this dimension and it inputs the value for me. So just one way so people don't have to remember a bunch of numbers if they don't want to. Now we have configured in our configuration tool to ensure that we have at least a 1/4 inch clearance on all our lifters. So what it does is it finds, well, what angle do I need for a rod to suit the ejector stroke of this job? What angle of a rod do I need to accommodate that 1/4 inch? Then from there we round up to the next nominal degree value. So this is kind of ensuring that everything is kept nominal, and we do have the option to go in here and choose a different number, so I can change it to say 6 3/4 or 6 1/2 if I wish. Okay. Another thing that I can do is I can reduce it down to say 3 inches. And what it's going to do is it's going to highlight this travel clearance in yellow. So what it's done is it's saying, well, now you're traveling less. Your travel clearance is less than the 1/4 inch that you spec'd out that you want everything to be. And maybe for this particular job, that's okay. Maybe you don't have the room to have any more, but it's highlighting yellow to let you know, hey, give you some kind of caution to let you know that you don't meet your company's standards or your customer standards. Right? I can also make it actually not pull far enough and it highlight red. Okay? And it's a situation that sometimes you will run into due to space, and you'll rely on the robots to get it peeled off and whatnot. So, or maybe it's being pulled off by hand or whatnot. So we do give you the flexibility to have these rods be exactly the way you want, but we by default go to whatever value you say in your config file. So we're going to stay with the 7 degrees. I'm perfectly fine with that. And in here we can choose different things. If it's a really big lifter, we can have it put in multiple lifter rods, things like that. For our ejector stroke, I can put in that I have front stops that are 1/2 inch thick, and it'll know to modify the ejector stroke based on those front stops. And then we have dowels holding the lifter rod to the head, and there's other options that we have in there too. The orientation of your dowels is we put in there your bushing types, if they're straight or shoulder, and the materials of your bushings, and how your bushings are being held in. So retainer ring is very common in our area of the industry. Everybody does it a little differently, and we want to accommodate all these different options. And same with the gib assemblies. So I'm going to leave these settings that you have here. This is what we use most often. Go ahead and say OK. And then it's going to just ask me, where's your lifter going to be? So your lifter head could be potentially inside an insert or anything, and we're able to do that. Okay, so go ahead and say OK. So then all I want to do is give a general area where I want that bottom of that lifter to be, right? So I can use my snap if I want to make sure things are nominal. It's totally up to me how I want to do that. Then once I'm happy with my location, I just go ahead and push OK. And then which direction is my rod going in? So is the rod going in this direction, or is it going in this direction? So it's going in this direction. So I just got to place my cursor over to the right. Okay? And then what it does is it goes ahead and it's going to just generate a basic lifter head for me. And as you can see, it's put in my bushings, my pipe spacers in there, my retainer rings in there, my material list will be all up to date, and my entire lifter gib assembly. So obviously everything is all done in 3D at the same time. So I'll go ahead and say show core half plate so I can see everything. And you'll see everything's all in there in 3D, all the holes for the lifter rod, all the pockets in the ejector plate, even the access holes for the screws are in there. So everything's all complete. Okay. So now we have a basic idea of this lifter, where we want to put it. And I'm going to leave it at that for now. What we're going to do now is we're going to just continue on with some ejection. So placing ejection in XMD is extremely easy. It's really just a single click on wherever you want to place it. So you remember we also have the ability to redraw our plates and our views to clean them up a little bit anytime we need to, and just like that, clean that. So what I'm going to do is I'm going to go ahead and add some ejections. So it's under the add function, and we have an ejector option. In here we have all kinds of different types of pins. We have ejector pins and return pins, which we utilized those a little bit last time. We have sucker pins, stepped ejector pins, and sleeves, and so on. So we're going to go ahead and put some ejector pins in. And I can choose from many diameters that are available out there in these different catalogs. And then we do have many vendors. So here's our different vendors in inch, and here's some different vendors in millimeters. Now, if you happen to utilize a vendor that you do not see in this list, what you do is you come to us, you let us know, hey, you don't have this particular vendor that we use, we need it in the software. We put it in for you right away. So it's not an issue at all for us to add vendors and add additional components. When we have ejector pins, the intelligence is already built in there, so we can add these to the software for you very easily. So you would come to us, let us know, we'll input all that information and get you a new version of XMD that will handle that. So this eliminates the need for your company to have somebody that is dedicated to creating all these components and keeping the software up to date. We take care of that for you on our end. Okay, so what we're going to do is everything that we see here is our standard options based on our config file, so we're going to go ahead and put it in. You do see there's a D-lock option. I'm going to go ahead and just leave that set to D-lock for now. And what I'm going to do is I'm going to place some ejector pins, and I'm going to only place everything on half of this job because the job is very symmetrical about this horizontal center line. So I'm going to go ahead and place a few ejector pins in there. Put some that are on contour so I can show you some cool things about that. And once again, I'm holding my snap down, and this is allowing me to put everything in nominal positions just with a single click without having to actually place them in a very specific location. So it makes it very easy. So I have my ejector pins all placed. Those ejector pins have all their sizes. The holes are all in their plates and everything. We're going to show you that. So if I go to my insert, you're going to see that my insert has that hole and it has the clearance. You can see the ream length is 1 inch because that's what we had it set to do. It takes care of all that for you. If I turn on my core block, you're going to see where the insert is. You're going to see the clearance hole ends at the bottom of the insert and understands where to go to. And you can see all the other ejector pins all have the proper length based on the solid. And the same thing applies for in the retainer plate. All the holes are applied to the retainer plate. And you can see all the D-locks and whatnot are all in there. All the holes. If I move these ejector pins around, those holes move with it. Once again, as we've mentioned in the past, you can do this in 2D or in 3D, it doesn't matter. Okay. On top of that, all the ejector pins have the contour added to them. So I can see, oh, I did not do a good job with where I placed that pin. And I can see that, and I'm able to fix that situation very easily by just shifting that pin over. So I can take this ejector pin and I can move it over to here, or I can move it up to here, wherever I want. Once again, I can do it in 3D so that I can see it a little more clear in real time. Or I can switch over there and you can see now I've got it in a really nice spot, nice and flat. Okay. So very easy to do. Now once again, if we use the modify button and I do modify size, I can choose one of these ejector pins and I can tell it I want to change all of them by type to maybe more ream. I want to go to all of type to 1.5 inches. And I say okay, and the ream length now is increased for every single one of them by 1/2 inch. So now it's 1.5 inches ream. Now I have the choice of saying single, so I could just change by that one, or I could do group, which would take care of ones that are symmetrically about each other in the tool. Right. And so now I have my additional ream because this customer for this particular job wanted the ream increased. Right. On top of that, some of these pins don't have contour on them, so I can go ahead and say, well, let's get rid of the D-lock on this one. Let's get rid of the D-lock on this one, and whatever ones do not need the D-lock, you can go ahead and remove that D-lock. And it's just like that. With a click of a button, the D-lock goes away. And you do have the option of which one that you do as a default. You can choose to depends on the type of work you do. For us, it's very rare for our pins to not be delocked, so we have ours set to automatically delock. So I can go ahead and select these ejector pins, and if I select this line, you'll remember the copy across line command from the last tutorial, and now I have my pins symmetrically opposite in the job. So that's how you can place ejector pins. It's very easy. You just go into a top view and start placing them, and everything's done. Okay, so now the customers come to us and decided they want an ejector stroke change. They want to utilize, let's say, more of the ejector stroke on their press. Right now we're using about 4 inches of ejector stroke. They've decided, you know what, we want to use 5 inches. Maybe it's better access for the robot or whatnot. Okay, well, here's what's really cool in XMD is when I make those changes, you know, this looks absolutely horrific. If I change this ejector stroke, my ejector pins have to get longer, my return pins have to get longer. It's going to change the long screws on my rails, my pillar supports have to get longer, my lifter rod angle is going to have to reduce. You know, right now I have a 7-degree lifter rod, and it's going to have to reduce to a different value. My ejector guides get longer. All these things have to change, and all this ejector box has to shift down. All these plates have to shift down for that new value. So once again, if we go into our modify, we go into our mold base editor, I can make those changes. So customer said, let's do about a 5-inch ejector stroke. So I do a 5-inch ejector stroke, and I look at what size that makes my rails. And maybe I said, well, you know what, that's not a really good size rail to order. You know, they got to grind a lot of material off of that rail. So let's increase those rails to 7 7/8. That way we can go with an 8-inch plate that they grind down to 7 7/8. And our ejector stroke is now 5.312, and the customer is perfectly fine with that. That's great. Go ahead and say OK. So now what it's going to do is it's going to increase all that ejector stroke. It's going to shift everything it has to shift down. It's going to increase the length of our ejector pins. And the biggest thing is it's going to increase or decrease the angle of our lifter rod. We no longer need a 7-degree lifter rod. We need, I don't know what angle we need. We'll check that when it's done, but it's all taken care of for me automatically. Right? Just like that. Once again, material list, everything is all up to date. Right? You're going to see our rails are now 7 7/8 long. And everything else that got updated with that is all updated in material list at the same time. So we're going to go to section B here. I'm going to take a look. Let's go to core plan view here. And let's show that lifter to section B. Haven't done that yet. So when I go to my section B, I should see a lifter in there now. And I can measure that angle to that rod. So I'm going to control verify angle. And now it's a 5-degree angle. So I didn't have to worry about that at all. It took care of all that for me. It's ensuring that I have a 1/4 inch of clearance all taken care of. Okay. So the last thing I want to do is we do want to finalize this lifter. Right now the lifter is kind of blocked in for us. It's given us some options, and now we have options on how we do it. Depends on how you work in your company. You can take that lifter and you can send that lifter block to whoever does your modeling. If you have somebody different that models all your parting line and all your lifters and slides and inserts and whatnot, we can send that blocked in lifter and say, here, this is what we want for the lifter, go with it. And then they'll send you the lifter, and you'll use the swap in feature that you've seen in previous tutorials for swapping in the solids. You'll swap it in and it'll be all up to date. If there's any changes in sizes that the modeler made, your material list gets updated automatically. Or we can model it directly in, which is something that we haven't really touched base on. So let's go ahead and do that. So the first thing I want to do is I'm going to pull up that lifter. Okay. And I want to just increase the height of it just a little bit. So get it kind of past the... So these commands that you're seeing me use are key creator commands. These are the direct modeling features that we have right built into key creator. Okay. So I'm going to click on this face now, and if I drag this down to the corner, I can kind of ensure that I'm adding my angles based on that particular edge of the solid. And I'll do the same thing here. I don't need to worry about the angle on the back of the lifter. XMD took care of that. We have it defaulted to be 3 degrees, I believe it is, more than the lifter rod, so it's taking care of all that for me. Okay. And then I'm going to put some rads in the corners here. So this is a decent sized lifter. Let's go with a 0.55 inch radius. That's a little bit more than the 1/2 inch. That way they go in there with a 1-inch cutter. They're not getting their cutter chatter. And then because I'm kind of coming up to the part here, maybe I need a variable radius on the front edge. So we're going to go ahead and put a variable radius in there. So I'm going to use key creator's point and radius pair option. And if I click the edge of this here, I'm going to go with, I don't know, 0.35 radius. And let's go along this here 1/2 inch with that same value. And then we'll go along this 1 inch with 200th thou. Okay? So it's kind of tapered down. We'll do the same thing over here. We'll go along it as well, 1/2 inch. And then we'll go along at 1 inch for that 200th thou. So now I have that taper. It's the same all the way through. Okay. So what I'm going to do here is I'm going to copy this. I'm going to copy this solid to another level. And that way what I can do is I'll use that bit of solid to actually pull the pocket out of my core block. In the meantime, I'm going to use the core block and use what's called connected faces to trim that solid to the shape of my core block. So what I'm going to do is I'm going to tell it to trim to connected faces. And by using connected faces, even though it's a solid, I can select it almost as if it was a trim sheet. Right? And then I have several faces I have to select. So the easiest way to do this is use key creator's feature commands. I'm going to use feature smooth. And what it's going to do is it's going to grab any faces that are connected smooth. Right? It doesn't matter if I have more faces than what I need. The main thing is that I at least have enough. So in 3 clicks, I'm able to grab all those faces. Basically, I grab the whole front face of my core block in those 3 clicks. It's a neat little feature. So I'm going to go ahead and say accept to that, and then I'm going to select the solid that I want to trim, and I want to keep the obviously the towards the back of the lifter, and that's it. I have my lifter complete just like that. So very easy, very quick. Got my lifter like that. So now what I want to do is I'm going to put a little chamfer at the bottom of that lifter, so it's not left sharp. Do that, and then I'm going to pull up my core block. And I'll pull up that solid that I copied, right? And I'm going to subtract that from my lifter. Okay, just like that. And I'm going to put a little 1/8 radius down there in the bottom. So do that again. Select the invalid line. There we go. So now we have radius down there at the bottom. Absolutely fantastic. And if I go to my section B, just to kind of show it to you, you'll see it all in there. And I can manipulate how this shows up in section. I want just a true section. I don't need to see the geometry behind in this case. And now it's a nice clean section. And I have my nice chamfers there, so it's cleared in that pocket. And I'll pull up my 3D core half, just so you can see it all. All right, and now I have the lifter all complete. I have my ejection all complete. So what's next? Next week, looks like we'll be doing water. Thank you. Have a good day.